I'm recording, okay? All right, so the first sequence lesson we learned was just this general lesson. It was the one where I gave you all those summation formulas and all that stuff. Then last time's lesson was arithmetic. That's when you add the same thing every single time. So this is the last sequence lesson, and it is geometric, okay? So a geometric sequence is when a number is multiplied over and over again, okay? So this is what I kept trying to stress to you on the last lesson. If you look at that first sequence, you guys, look. 2 plus 4 is 6. Is 6 plus 4 18? No, sorry. Is 6 plus 4 18? No. So I know it's not arithmetic. So once I determine it's not arithmetic, then I'm like, okay, maybe it's a geometric. So 2 times 3 is 6, and 6 times 3 is 18. So I found it, okay? The ratio is 3. The ratio is the number that you're multiplying by, okay? So now this is easy. I just go 18 times 3. I get 54. 54 times 3 is 162. 162 times 3 is 486, okay? Now look at the next one. This is where it maybe gets a little difficult. You can see that the signs are alternating, positive, negative, positive. Well, the only way that's going to happen is if your ratio is a what, everybody? A negative, okay? Here's another kind of tricky thing. The numbers are getting smaller. Disregard the sign and just look at the numbers. So 32 to 16 to 8, the numbers are getting smaller. So what do I do to 32 to get a 16 divided by 2? 16 divided by 2 is an 8. So I can't say divide by 2 though. I have to say multiply by something. So dividing by 2 is the same thing as multiplying by what, everybody? 1/2. Good. So I'm going to multiply by a negative 1/2, multiply by a negative 1/2. I know my ratio is a negative 1/2. I'm going to think about it as divide by a negative 2 because that makes more sense to me. So 8 divided by negative 2 is a negative 4. Negative 4 divided by negative 2 is 2. 2 divided by negative 2 is negative 1. Okay? All right. Now we're going to come up with the formula. Okay? Just like we did before. So you guys know that A and A sub 1 mean the same thing, and that stands for the first term. When we did arithmetic, we had a D, and that was the common difference. This is an R, and that is called the common ratio. Okay? Now, let's come up with the formula. So look, underneath A, everybody put n equals 1. A times R, n equals 2. And then n equals 3, n equals 4, n equals 5, and n equals 6. So we have A, then A times R to the first, A times R to the second, A times R to the third. This is obviously A times R to the fourth, and this is A times R to the fifth. Okay? So now we're going to come up with the formula. Okay? You guys are going to help me. So every single one of those terms has an A, and it's multiplied by some kind of ratio. Now I want you to give me the rest of the formula in terms of n, but give everybody a chance to think about it. So if n is a 1, you don't have any r. If n is a 2, you have an r to the first. If n is a 3, you have an r to the second. 4 is an r to the third, etc. So tell me what about that r. What do I do to it? I raise it to the, tell me, n minus 1. Awesome. That's the formula. Okay? You use that formula when you're looking for a specific term. Okay? You have to memorize that. Write that down. Memorize. Okay. The sequence that's given, this formula is given, is geometric. Find your A and find your R. Okay. Well, let's find a few terms, guys. Let's go A sub 1, A sub 2, and A sub 3. So I'm finding A sub 1. That means n is a 1. So that would be 3 to the first, which is just a 3. If I'm finding A sub 2, that means n is 2. So that's 3 squared, which is 9. If I'm finding A sub 3, then n is 3. That's 3 to the third, which is 27. That's enough. So A, I already found. That's the first term. That's a 3. The only other thing that they want is the common ratio. That's what I'm multiplying it by every time. Well, 3 times 3 is 9, and 9 times 3 is 27. So my ratio is 3, and I'm done. I think geometric is easier than arithmetic, by the way, just so you know. Okay, example 2. Find the first 5 terms and the 15th term if A is 3 and the common ratio is 2. Now, I was just going to say they really should tell us that this is geometric, but they really do tell us that it's geometric. How do you know that? They say ratio. If it was arithmetic, it would say common, tell me, common difference. Good. Okay, so we know that the first term is a 3, and we know that the common ratio is a 2. So if a sub 1 is 3, that means a sub 2 is a 6. You multiply by 2, and then 6 times 2 is 12. Okay, let's keep going. They want the first 5 terms. So 12 times 2 is 24. 24 times 2 is 48. So let's list those as a sequence, 3, 6, 12, 24, 48. They're your first 5 terms. Okay, and then the other thing they want is the 15th term. So guys, the symbolism for the 15th term is a sub 15. You need to understand that. Okay, so to find the 15th term, you use the formula a sub n equals a times r to the n minus 1. So a sub 15 is a, which is 3, multiplied by the common ratio, which is a 2, raised to the n minus 1. Well, if I'm finding a sub 15, then n is 15. 15 minus 1 is 14. Okay, grab your calculator. Everybody go 3 times 2 to the 14th, hit enter, and your answer is 49,152, and we're done. Pretty straightforward. Okay, next one, find the 22nd term. Okay, so everybody look right here. Let's pretend like this was on a final. Okay, look. I'd say, okay, let me see if it's geometric. 9 subtract 6 is 3. Is 6 subtract 3 1? No. So I know it's not arithmetic. And then I go, okay, and maybe it's geometric. And then I say, well, the numbers are getting smaller. So I still have to think about it as multiply. But don't think about it as multiply for a second. What do I do to a 9 to get a 3? Divide by 3. Is 3 divided by 3 1? Yes. So I can see that I'm dividing by 3, which is the same thing as multiplying by, tell me everybody, 1/3. Good. So I know that my ratio is 1/3. And now I'm going to use the formula a sub n equals a times r to the n minus 1. So that's going to be a sub 22 is the first term, which is a 9, times the common ratio, which is a 3, raised to the 22 minus 1 is 21. Grab your calculator and go 9 parentheses 3, close it, raise it to the 21st, hit enter. Okay, now I get this big crazy number. Do you get this big crazy number and then like some 10? Okay, so this is what this is saying. This is not going to happen on your test, just so you know. I know they won't do this to you. So this means 9.4 times 10 to the 10th power. Oh, it is supposed to be 1/3. Thank you. I put a 3. It's supposed to be a 1/3. Let's do it again. Thank you. Let's do it over. Okay, so everybody go 9 parentheses, 1 divided by 3, close it off, raise it to the 21st, hit enter, and I still get a crazy number. Did we get a crazy number again? Okay, so let me tell you what that means. It's 8.6 times 10 to the negative 10th power. That's how you read that. So it's scientific notation. Why did the calculator put it in scientific notation? Because it's so small, it can't handle it. It can't handle it, can't write it properly. How do I know this is so small? Can anybody tell me? Because that negative 10 tells me to take that decimal and go 10 digits to the left. So it's 0.0000000086. Okay, it's not going to happen on the test. Don't worry about it too much. Okay. Okay, here's the formula for the sum of a geometric sequence. Okay, write a note right here to yourself that says, I must memorize this. A, you guys know it's the same thing as a sub 1, which is the first term. R is the common ratio, and n is the number of terms that I'm adding. So if they say find the sum of the first 20 terms, then your n is a 20. Okay? All right. Find the sum of the first n terms in this sequence. Okay? Well, I need to know what a is, I need to know what r is, and I need to know what n is. Okay? So a is the first term, which I don't know yet. R I don't know yet. And n, do you see how it says n terms right here? Let's highlight that and let's write down again that we're going to have an n in my answer. If they said find the sum of the first 16 terms, then I know that n was 16. I wouldn't have an n. They didn't tell me, so I'm going to have an n. That's fine. Let's find a. So everybody go a sub 1 equals 1/2 to the first power. That's just a 1/2. So now I know a is 1/2. And now let's find a sub 2. So a sub 2 is 1/2 to the second. That means 1 to the second is a 1, 2 to the second is a 4. Let's do one more. A to the third is 1/2 to the third. 1 to the third is a 1, 2 to the third is an 8. Now let's find the ratio. What do I multiply by 1/2 to get 1/4, everybody? What is that? It's not 2. See how the tops are just all staying 1s? So that'd be a 1 over, and then what goes on the bottom? A 2, yeah. So the ratio is 1/2. Okay, so let's put that in the formula. So the formula is S sub n equals a, and then I'm going to do a bracket, 1 minus r to the n over 1 minus r. Now I do have the r on the top in parentheses, so you need to put parentheses around it. Okay, so the sum of the first n terms is a, which is 1/2, bracket, then you go 1 minus, in parentheses, put the ratio, which is 1/2, to the n power over 1 minus the ratio, which is a negative 1/2. Okay? All right, now, I think everybody's probably good to right there. Who says I'm good? Give me some feedback. See how we're doing. Okay, I'm going to show you something. It's a little confusing, so I want you to watch. Okay? It's not fully simplified. Here's why. Look at the bottom. What is 1 minus 1/2? Everybody tell me that. 1/2. So I'm dividing by a half. Dividing by a half is the same thing as, can you tell me? Multiplying by 2. So I'm going to get rid of this, and I'm going to multiply the whole thing by 2. Because dividing, look at this, guys. Because dividing something by a half is the same thing as multiplying it by 2 over 1. Remember, you flip it. So that stuff right there is gone. And now look what happens in the front. What is 2 over 1 times 1 over 2? What is that? That's just a 1. The 2's cancel. So your final answer is S sub n is 1 minus, in parentheses, 1/2 to the nth power, and we're done. Okay? Any of these could be on your final. I've never seen anything up to this point on the final yet, just so you know. Okay? Okay, let's do the next one. Find the sum of the first 6 terms. We know that it's geometric. Let's pretend like we don't know. Okay? Watch me do this. 27 subtract 18 is 9. Is 9 subtract 18 3? No. So I know it's not arithmetic. Okay? The numbers are getting smaller. 27 divided by 3 is 9. 9 divided by 3 is 3. So dividing by 3 is the same thing as multiplying by a third. Okay? So I know that my ratio is a third, and I know my first term is a 6. And I'm trying to find the sum. So the formula is S sub n is n bracket 1 minus the ratio to the n power over 1 minus r. So the sum of the first 6 terms is 6 Oh, did I do something wrong?
Term 27.
Say it again.
The first term should be
Oh,
27.
gotcha. Thank you. This should be, oh, that's an A. I put N, that's why. This is A. So the first term is 27, thank you, times 1 minus the ratio, which is 1/3 in parentheses, raised to the n power, which is a 6, over 1 minus 1/3, okay? Now, there are no variables anywhere in what I wrote. The reason there are no variables is because they said find the sum of the first 6 terms, and up here they said the sum of the first n terms. So I don't have a variable. So I'm going to have to put this in my calculator. Now look right here and let me show you how to do it, okay? Around the top, you have to add parentheses right here, and also around the bottom. Now everybody just look for 2 seconds before you start punching, because sometimes people struggle with these calculators. Oh, sorry. Excuse me. With this calculator stuff a little. So just watch. 27, parenthesis, 1 minus parenthesis, 1 divided by 3, close parenthesis, raise it to the 6, close parenthesis, divided by parenthesis, 1 minus 1 divided by 3, close parenthesis, enter. So it's exactly what you see, as long as you add those parentheses around there. Okay, let's do it. Everybody go 27, parenthesis, 1 minus parenthesis, 1 divide 3, close parenthesis, raise it to the 6th, close parenthesis, divided by parenthesis, 1 minus 1, divide 3, close parenthesis, hit enter, and I get 40.4 repeating, okay? Now, let's turn that into a fraction. So everybody hit second PRB, enter, and what you see on your calculator means 40 and 4/9, and that's your answer, okay? There are definitely problems where they're going to say, do not write this in decimal form. So if you get a weird decimal, just hit that second PRB. Hopefully it will give you a fraction, okay? Sometimes it does, sometimes it doesn't. Okay, find the sum of the first 10 terms. You guys, I can see that this is geometric because 3 times 2 is 6, 6 times 2 is 12. So I know that my A is a 3, and I know my R is a 2. So this S sub 10 is the first term, which is a 3, bracket, 1 minus 2 raised to the 10th over 1 minus 2. Now, I didn't put parentheses around the 2. You don't have to put parentheses in this scenario. The time that you do have to put parentheses around that ratio is if it's this or if it's this, the ratio. Can anybody tell me when would I have to add parentheses? If it's a negative or if it's a fraction. You're exactly right. Well, let's say I didn't know that. And let's say I put parentheses right there. Does it matter? No. So maybe it's better to be safe than sorry and you always just put parentheses. But I want you to understand you don't have to, okay? When you put this in your calculator, you do have to add parentheses around the top and the bottom, okay? Let's do it together. Everybody go 3, parenthesis, 1 minus parenthesis 2, close it, raise it to the 10th, close parenthesis, divided by parenthesis, 1 minus 2, close it, hit enter, and my answer is 3,069, and I'm done. Okay, I forgot to make one comment. Sorry, look up here for just a second. When we had this problem right here, example 4, do you see how this was a 1/2 in parentheses raised to the n? If they give you a formula and you have something raised to the n, that something right there is always going to be your ratio, okay? Let me show you the same thing right here, okay? So add the numbers together, find a summation, use that formula from n equals 1 to n equals 6, okay? So you're finding the sum of the first, how many terms? Somebody tell me. Find the sum of the first 6 terms, sure. So here's my formula, S of n equals A times 1 minus r to the n over 1 minus r. Okay, now let's list out what we know. We need to know A, and we need to know R, and we need to know N. You guys, do you see how you've got that parenthesis and then it's raised to some kind of an N? That's your ratio. So I'm just telling you right now your ratio is -1/2. Okay? The number of terms that I'm adding together, we know that. That's a 6. So the only thing that I don't know for my formula is the value of A, the first term. Well, I'm just going to put in a 1. So everybody go, A sub 1 is 12 times -1/2 to 1 minus 1. Well, 1 minus 1 is a 0, and -1/2 to the 0 is a 0, and then I just get a 12, okay? So this number in front is always going to be your A, okay? Now let's plug it in. The sum of the first 6 terms is 12, bracket, 1 minus, do I have to put parentheses around the ratio on this one, everybody? I do. So it's a -1/2 raised to the 6th all over 1 minus, and again parentheses, -1/2. So there's my setup. When I put this in my calculator, I have to add parentheses around the top and the bottom. Let's put this in. You put it in by yourself, okay? When you get that decimal, hit second PRB. You should have gotten 7 7/8, okay? Does anybody need me to read the buttons that you need to push to get that 7 7/8? Everybody's good? Okay. Infinite geometric sequence, okay? This is a little, I have to explain a lot of things for you to understand this, okay? So I want you to go like this, guys. Everybody put an example right here and an example right there. Just squeeze it in somewhere, okay? Look at this one. 1 plus 2 plus 4 plus 8 plus 16 plus blah, blah, blah. Okay? I'm trying to add those together. A sum of a sequence that doesn't stop. It's infinite. Okay? You guys, are those numbers getting bigger or are they getting smaller? They're getting bigger. So what if I added the first 1,000 numbers together? Let's just say 1,000. And I got this number. But then the 1,001st number is going to be big. And it's going to have a big effect on this sum. So no matter where I stop adding, the next guy is definitely going to change the sum that I had before. Who says I understand that, what you're saying to me? Okay, so this right here is called diverges. Those numbers are getting bigger, okay? It looks like this. The numbers start small and they get bigger and bigger and bigger and bigger. Okay, my ratio on that example right there is what? Everybody tell me. What am I multiplying by those numbers by every time? 2. My ratio is a 2. If your ratio is bigger than 1, then it diverges and the sum is not possible. You can't add it together because they just keep getting bigger and bigger and bigger. Okay, okay, look at this one. 100 plus 50 plus 25 plus 12.5 plus 6.25 plus blah, blah, blah. Okay, now here's where it gets maybe a little confusing to understand. Someone tell me what my ratio is. What's my ratio? It's 1/2. I'm dividing by 2, right? So imagine this. My ratio is less than 1, so that is called converges. The picture looks like this. Look, the numbers start big and they get smaller and smaller and smaller. Okay, it's coming down to a point because they're getting teeny, teeny, tiny. Okay, everybody listen to this. I have this big, 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 long series of numbers. And the numbers are getting smaller and smaller and smaller. So if I go clear down over there, and I say, okay, that's where I'm cutting it off. And then I add all the numbers together and I get this number, okay? The next number that I didn't add in, is that number big down there or is it tiny? If the numbers start big and they get smaller, 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 okay? Look, I'm clear down here and I'm like, okay, stop. I add all these numbers and I get my number. The next number that I didn't include, everybody in the room tell me, is it big or is it small? Small. If I went like 1,000,000 numbers, 1,000,000, numbers count. Thank you guys so much. You guys are awesome. Thank you. Okay, so I add 1,000,000 numbers and I get the sum. Then the next number, you said small, like 1,000,000 numbers. Teeny tiny or just kind of small? Which one? Teeny tiny. So is a teeny, 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 tiny number going to have a big effect on that sum? No. Okay, so it's possible. It's possible because the numbers get so small that it almost has no effect. Okay, so this converges and it's possible. Okay, so before you find the sum, you have to decide if it converges or diverges. Okay, so this one converges, so it works. Okay, so look up above. If you have an infinite series and it converges, which means the ratio is less than 1, then here's your formula. Okay, right there. It's really pretty simple. Okay, now I want you to put stars around number 7. This is the one that showed up on the final. Okay, I think I'm going to add a C in here. I'm going to do an A and a B and a C because I want to really show you what was on there. Okay, so it's probably not going to say decide if it converges or diverges. It's just going to say find the sum. Well, look what you have to do. You have to notice that it's an infinite series. As soon as you notice it's an infinite series, then you say the sum of an infinite series is a over 1 minus r. But I know I can only find it if my r is less than 1. So you can just look at the numbers. First you have 2, then you have 4/3, then you have 8/9, then you have 16 or 27. Are those numbers getting bigger or are they getting smaller? They're getting smaller, so I know it converges. So I know I can do it. I also have to find the ratio. Guys, look. Put a 1 underneath a 2. What do I multiply by 2 to get a 4? A 2. What do I multiply by 1 to get a 3? A 3. Let's check it again. Is 4 times 2 8? Yes. Is 3 times 3 9? Yes. So I know that my ratio is 2/3, which is less than 1. Okay? So let's do the formula. Sum of an infinite series is A, which is 2, over 1 minus 2/3. I'm just going to put this in my calculator, but I have to remember to put parentheses right there. So everybody go 2 divided by parentheses, 1 minus 2 divided by 3, close it, enter, and my answer is a 6, and I'm done. So the one that came up on the final was really pretty straightforward. It was pretty okay. I am going to squeeze in another problem though. Okay, here's question B. You have to stay on top of it. Yes.
Wait, sorry, just make sure. So for A, so if you added up all of those numbers, it would equal 6.
Yes. Yep. You believe me? She doesn't believe me. It's true. Because they keep getting smaller, 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 smaller. It's almost like, this is what it's like, Hope. Hope is very smart girl. Look what it happens. It's just like an asymptote. It gets really, 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 really close to 6. It actually never gets there, but it gets really close. Okay? It's 6. Okay, here goes question B. If you get a question like this on your final, you must notice there's something in that summation that is super, super important. What is it? It's the infinite right there. So now you know it's the sum of an infinite series. Okay, everybody focus. Shh. Everybody focus. So as soon as you see that, you say a sum of an infinite series is A over 1 minus R. Now, I can look at that formula and I know what A is and what R is. Do you guys know now? What's A? 8. And what's your ratio? 1/3. Okay. The ratio is less than 1. 1/3 is less than 1. So I know that this converges. Okay. So the sum of an infinite series is A, which is 8, over 1 minus 1/3. Put parentheses around the 1/3 and let's just put it right into our calculator. So we're going to go 8 divided by parentheses, 1 minus 1 divided by 3, close it, enter. I get a 12 and I'm done. Okay, I'm going to add a problem. Sorry. Question C. Okay, 12. Negative 24/3. Positive 48/9. Negative blah, blah, blah. Find the sum. My signs are alternating, right? If the signs are alternating, then I know my ratio is a what? A negative, okay? This is 12 over 1. What do I multiply by 12 to get a negative 24? Negative 2. What do I multiply by 1 to get a 3? A 3. Let's see if it works again. Let's see if negative 24 over 3 times negative 2 over 3 works. A negative 24, first of all, the negatives, I don't like how I said that. I don't like how I said I incorporated the negative in there. We know it's a negative, you know, that's why the signs alternate, so forget about it. I wish I would have rather said, what do I multiply by 12 to get 24? That's a 2. What do I multiply by 1 to get a 3? I knew it was a negative, so I didn't have to talk about negatives. Then 24 times 2 is 48. 3 times 3 is 9, so it totally works. Okay, so your ratio is negative 2/3. This is what it looked like on the final. So everybody star this. This is the guy right here. Now, when you're deciding if it converges or diverges, you disregard the sign of the ratio. So don't worry about the negative. I'm looking at the 2/3. 2/3 is less than 1, so I know that this converges. Okay, so that's a little tricky. Disregard the sign. It's just the number that you're looking at. Okay, so the formula is the sum of an infinite series is A over 1 minus R. So for this guy, sum of an infinite series is 12 over 1 minus. Now it's minus a negative 2/3, which is going to be a positive 2/3. Okay, put parentheses around it like that. And then you go 12 divided by parentheses. 1 plus 2 divided by 3, close your parentheses, hit enter, and you get 7.2. Now let's see if it's a nice fraction. Hit second PRB, enter, and it is 7 1/5, and that's how I'm going to write it. That was on the final last semester. Okay? Yes, honey?
What do you do if it's...
Just a sec, sorry. Just a sec. Guys, will you be quiet, please? Okay, go ahead.
What do you do if it doesn't go in the fraction meeting?
And sometimes it doesn't. Then just leave it as a decimal. And I would say approximately. Okay? All right. Question 8. A statistician knows that a town of 3,600 people, this is a little confusing, has a predicted growth rate of 6% per year for 20 years. What should she predict the population will be in 20 years? Notice it's a she. She's a female. Because she's smart. You have to be very smart to do this, so it's a girl. Okay? Okay. If they give you a percentage, okay, if they give you a percentage of increase or decrease, it's always geometric. So everybody put geometric. Okay? Okay, quiet please. So the first year, the population is 3,500. I have to figure out the ratio. This is confusing, so I want you to watch. it says it grows by 6%. So 6% as a decimal is 0.06. Okay, so that means the second year, 3,500 times 0.06 is 210. That means the second year my population is 210. Is that correct? No. 210, what does that 210 represent? How many more people join that population, right? So what am I going to do? I cannot put plus 3,500 at the end. A ratio is something you multiply by. So how do I pull in that 3,500? Put a 1 in front of it. Yes. The 1 times 3,500 gives me the 3,500. The 0.06 gives me the 210, and then it pulls it together, and I get 3,710. Okay, so I want you to write this down. If it is growing by a certain percentage, then you have to go 1 point and then the rate at the end. Otherwise, it's not going to get bigger. It'll diverge because your ratio is less than 1. Okay? Okay, so there's my information. And what would she predict the population to be in 20 years? So guys, listen. Listen to all these formulas we have. Okay? Write these down for me. A sub n equals, don't look around, try to remember. Do you remember that first formula? A, talk to me, times R, do you remember? To the n minus 1. And then we had S sub n is, what's that one? A, that's A and then bracket. It's okay, we're just learning. 1 minus, in parentheses, R to the n over 1 minus R. There's one more formula. What is it? Sum of an infinite series is A over 1 minus R. So I have to decide which one. Okay? What would she predict it to be in 20 years? If you think it's a sum, listen what you're doing. You're taking 3,500 and you're adding it to 3,710 and then you're adding it to the next one. People are going to be counted like 20 times. That's not it. It's this formula right there. It's a specific year. Who says I understand that? Raise your hand. Okay. So A sub 20 is the first term, which is 3,500, parenthesis, 1.06 raised to the 20 minus 1, which is 19. So everybody go 3,500, parenthesis, 1.06, close it off, raise it to the 19th, hit enter, and we're going to round it to the nearest whole person, okay, which is 10,590, and you have to write the word people, and we're done. Okay, one more problem with lots of little parts to it, and then we're done. Okay, it's all right. You're going to be fine, whiners. Okay. Suppose that the motion of an object through a certain medium is such that it travels 90% as far each second as it did the preceding second. If it moves 50 feet in the first second, answer the following questions. Everybody listen. I have a Nerf gun. My Nerf gun is in the water, and I'm going to shoot my friend with it. So I pull it, okay, out comes the Nerf gun, and at first it goes fast, and then it goes slower and slower and slower, because it's traveling through, tell me, water. Now this is a very powerful Nerf gun, because it travels 50 feet in the first second. So it's maybe like, you know, airsoft gun or something, I don't know, okay? Okay, so everybody watch, okay? Percentage means that it's what? Tell me. Arithmetic or geometric? It's geometric. Immediately I know it's geometric. Okay? The first second it travels 50 feet. The second, okay, listen what it says. 90% as far as the previous second. So think about it in terms of the gun. Is it going to start speeding up? No, that's silly. It's slowing down, right? If it's slowing down, I know that it's converging. Okay, it converges. Just keep that in mind. If it's slowing down, then your ratio has to be less than 1. It's getting smaller, right? 90% is 0.9. Should I add a 1 in front of that? No, that'll make it go faster. That means it's growing in speed, in distance and speed. And it's not. So there's my ratio. Okay? So just so you can wrap your brain around it, the first one's 50. The next one's 50 times 0.9, which is 45. That's the amount of the feet that it travels. Okay? So let's write down all of our formulas. Let's come off to the side and go a sub n equals a times r to the n minus 1. S sub n is equal to a times 1 minus r to the n over 1 minus r. And then the sum of an infinite series is a over 1 minus r. Let's label these 1 and 2 and 3. And the first thing we have to do on each problem is figure out which formula to use. Okay, so read the first question. How far will it travel in the 15th second? You tell me. 1, 2, or 3? If they wanted 2, let's think about it. Everybody listen. If they wanted 2, they would want the first second plus the second plus the third. How would it be worded if they wanted it to be equation 2? During the first 15. But they want it just in. So they want equation 1. Okay? So everybody go a sub 15 is equal to a, which is 50, times the ratio, which is 0.9, raised to the 15 minus 1 is 14. Grab your calculator and go 50 parenthesis, 0.9, close it off, raise it to the 14th, hit enter, and we're going to go 2 digits. On this whole example, we're going 2 digits, okay? And that would be 11.44. If you don't label, you're going to lose points. What would it be? It would be feet. Good. Okay, let's read the second one. How far will it travel during the first 15 seconds? You tell me which equation. 2. Why not 3? Because it's 15. They gave us an ending point, right? So this is the sum of the first 15 seconds. Is the first one, which is 50, bracket, 1 minus, in parentheses, 0.9 to the 15 over 1 minus 0.9. Let's put the whole thing in the calculator, adding parentheses around the top and the bottom. Okay, so everybody go 50, parenthesis, parenthesis, 1 minus parenthesis 0.9, close it, raise it to the 15th, close it, divided by parenthesis, 1 minus 0.9, close it, enter, and this is 397.05, and that would be feet. By the way, hit second PRB, enter, and you see how it does not give me a fraction. So sometimes it's a good fraction, sometimes it's not a good fraction. So don't worry, okay? Just check, and otherwise you're fine. Yes?
How do you know, like, if it belongs in the fraction and it doesn't say, like, how many decimals
We were there are 2 things. They're starting to get way more specific, which is good, round to this. And if they don't tell you specifically, then they're pretty giving with what you do. So they're not too strict about it. Okay? Okay. How far will it travel in the nth second? Think about this, guys. How far will it travel in the nth second? You tell me what equation 1, 2, and 3. It is equation 1, specific second. But I don't know what is on this. I don't know what n is because it said nth second, right? So this is going to be a sub n equals a, which is 50, times the ratio, which is 0.9, raised to the n minus 1. That's your answer. There's nothing I can do to that. Okay, I just put in my numbers and my n stays an n. Okay, how many seconds will pass before the object travels less than 15 feet in that second? Well, in the first second, it already travels more than 15. So what they're saying is, how many seconds pass until during that second, it travels less than 15? Who understands what I'm saying? Raise your hand. Okay, so listen. Okay, no, lots of people aren't, so listen. Here's another thing. Okay, I'm trying to be like very optimistic, and I'm trying to be very motivating. I want you to think about what your quiz scores and test scores have been lately, and I want you to think about what you're facing in a week and a half. Okay? So maybe we should stop giggling and talking, and maybe we should focus. Okay? Because it's going to be here before we know it. Okay? So let's focus. We're almost done. Okay. Listen what the question is asking you. The first second, it travels 50 feet. The second second, it travels 45 feet. The third second, it's going to travel less than that, and then less than that, and then less than that. So the question is, how many seconds are going to pass by until the feet for that second is less than 15? Who says, now I understand what you're saying? Okay. What formula? You tell me, 1, 2, or 3. Specific second. Tell me. 1. Okay. So everybody go. Well, it's going to be, okay, I'm going to use this formula right here. Basically, there it is. That's a specific foot, so a specific second. I'm going to let the distance traveled, which my a sub n, be 15. So everybody go, 15 equals 50 times 0.9 to the n minus 1. Everybody look at that and stay calm. What are we going to have to do? You're going to have to convert it. How do you know you're going to have to convert it? What you're solving for is stuck in the exponent, right? Can I convert it right now? What do? Divide by 50. So now I have 0.9 to the n minus 1 is equal to 15 divided by 50 is 0.3. Now I'm ready to convert it. So it's going to be log base 0.9 of 0.3 is equal to n minus 1. Bring my 1 over, and I have n equals 1 plus log base 0.9 of 0.3. Bless you. Now let's make sure you remember how to put that in. Okay? Everybody go 1 plus log 0.3, close it off, divided by log 0.9, close it off, hit enter, and you get 12.427, we'll say. So the question is it 12 or is it 13? Well, when the 12 second hits, or when the 12 second hits, it's after that it slows down. So during the 12th, will it be less than 15, or is it during the 13th? Well, let's check. If you don't know, let's check. Put right here, let's put in a 12. So everybody go 50, parenthesis, 0.9, close it off, raise it to the 12 minus 1 is 11, hit enter. Is the answer 12? No, because it traveled more than 15. So the answer is 13 seconds. It's the next one. If you put in a 13, you're going to get something less than 15 for feet. Okay? All right, question E, and then we're done. Then we have one more lesson to learn. Just one. And it'll be on the final. These last 3 weeks have been so much. Think about matrices, all those matrices, and systems.
Wait, is the last lesson?
Say it again.
The last lesson hard. I heard it's really tough.
Let's just focus on this one right now, Jesse. Don't look too far in the future. Okay.
Yeah, that's tomorrow.
Oh, tomorrow? Okay, well, let's worry about that tomorrow. Okay. Question E. How far will it travel before coming to a rest? Okay, so look right here. goes 50, 45, smaller, 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 smaller. I'm being annoying on purpose. Smaller, smaller, smaller. What am I talking about? I'm converging. I'm talking about what kind of a sequence? Infinite. Keeps on going. That distance that it travels gets so small that it doesn't even affect it. So what formula are we talking about? Formula number 3. Yes. So the sum of an infinite series is a, which is 0.9, over, nope, a, which is 50, sorry, over 1 minus 0.9. Parentheses around the bottom. So you go 50 divided by parentheses, 1 minus 0.9, close it off, hit enter. Your answer is 500. 500 what? Feet is correct. Good. Okay. Okay, so we still have like 20 minutes. Okay.